Thank you for coming back. How are you? Alright, today we are going to study on electricity and we will work on the topic of effective resistance between 2 points in the circuit and also using V equals to IR. And I am sure that if you follow me closely today, you will learn effectively some of these concepts again. And to learn effectively, you need to be doing rehearsal all the time. Take out your pen, your pencil, your notebook, your calculators, and we are going to work through questions. That is the way to study effectively. Output revision, you work at it, answer questions, answer past year examination questions, and you will do well. Remember, do not be just tempted just to read your reference book over and over again, because that does not help very much. At the end of this lesson, you should be able to calculate the effective resistance between 2 points. And secondly, you would be able to make use of the value of the effective resistance and to calculate another quantity in the equation V equals to IR. Let's take a look at the question. A very simple question, very short and sweet. Number 36. Diagram 20 shows an electric circuit. What is the reading on the ammeter? Is that all? Yeah, that's it. What is the reading on the ammeter? Alright, we have to do a lot of writing to understand a question like this. So number one, we have to ask first the question. What is meant by the reading on the ammeter? Alright. The reading on the ammeter means the electric current. So in short, we actually want to calculate what is the current. Alright. So this is positive here, negative. So we want to know what is the current. What is the electric current flowing in the circuit? Number 2, let me label this point X and label this point as Y. Alright? So between X and Y, we notice that there are 2 resistors there. The 6 ohm resistor and the 4 ohm resistor. And these 2 resistors are in parallel. Alright? So what we need to do is, we need to work out the effective resistance between X and Y. Alright, I can call this R1, the first resistor, and I call this R2, the second resistor. Alright, so let us do it step by step. Okay, here we have some space to do the calculations. Alright. I'll start from on the left hand side. Now once again, we want to calculate what is the electric current. And what is the 6 volts? What quantity is it? It is the potential difference, alright, across XY, which is 6 volts, alright. So in other words, I use V equals to 6 volts. Alright, I can put V for volts or I write it in full. Okay, we have to calculate what is the current in the ammeter. Here I have R1 and R2, 2 resistors. So what I need to do now is, I need to calculate the effective resistance between X and Y. Alright, so I will write down what is the effective resistance between X and Y. Alright, so once I get this, once I obtain RXY, I can calculate I. From the equation, V equals to IR. Now this is so common an equation that you need not even refer to the formula page. You have used it time and again. So V equals to IR. Okay, so now let me guide you how to calculate RXY. Now Rxy is the effective resistance between X and Y in parallel. So there is one equation which is 1 over R. In this case, it is from X to Y or between XY. This is 1 over R1 plus 1 over R2. This is very simple, but you must be very careful. You must not make any mistake. So what is R1? 6. Am I correct? Now I have done this intentionally. Am I correct? No. What did I miss out? The units. Write down the units. Without units, strictly speaking, it is wrong because it does not mean anything. 1 over R2. What is R2? 4 ohms. Alright, now we are very careful. We put down 4 ohms. I would advise that you write this down again. 1 over R XY. Very good. So we work this out. Okay, do the mathematics. Okay, I will do simple mathematics. What do I have? I've got 12 ohms here divided by 6. I've got 2. Plus 12 ohms divided by 4 ohms plus 3. Alright, so I would have 5 divided by 12 ohms. This is 1 over Rxy. Now this is very, very important. Okay, this whole thing that I have just done, the whole equation here is very important. Many students make a mistake. They said that Rxy is equal to 5 divided by 12. And that's wrong. Okay, what is Rxy? Rxy is now equal to 12 ohms divided by 5. I cross multiply. You see, it is very important to write units down. Once I have written the units, and when I write down the value 12 ohms over 5, I have even got my units correct. Okay, so that is equals to 2.4 ohms. Alright, so far so good. So that is my Rxy. So I come back to the question now. The question is, what is the ammeter reading? Alright, allow me to write on the left hand side now. So from V equals to IR. Now this R is from Rxy. Now actually the V is also Vxy. Actually the current is also from X to Y. Alright, the current is actually the current in the whole circuit. It also involves from X to Y. Alright, but I won't write it down so that I will not complicate matters. So I equals to Vxy divided by Rxy. What do I get? Vxy is 6 volts. And what is Rxy? 2.4 ohms. Okay. So 6 volts divided by 2.4 ohms. Now you can use your calculators and you should be able to get the final answer. Alright, the answer is 2.5 amperes. Alright, 2.5 amperes. Okay. So that is the final answer. That is the ammeter reading, which gives the electric current. So you see, boys and girls, even in a simple question like this, there are many concepts, there are many things to do right. And once you do things right, you will be alright. Okay? So once again, go back, look for questions that touch on V equals to IR, that touch on effective resistance between 2 points, whether parallel or in series or both, a mixture. You must practice it and you will understand the concepts. Then you will improve. Then you will get your A. Alright, so with this, I would like to thank you very much once again for joining me in this session, and may God bless you. And here is Uncle Pang teaching you. Thank you.